Hi everyone, my name is Daniel Boxer, and today I'd like to show you a project that I've been working on for the past year or so. This project is an experimental operating system with the goal of maximizing the user's time while minimizing the software layers within the system. This demo will be running on real hardware, bare metal. It will be running on my desktop, which has a Intel Core i5 Kaby Lake with 16 gigabytes of RAM. Before I proceed, I'd like to say that while I am a programmer by training and trade, this is the first time I've worked on an operating system in any real capacity. So I hope you can see some value in the demo I'm going to show. So with that, let's get started. So the first thing I want to show is how to launch an application on the system. Currently, the way to do this is to bring the mouse cursor to the place that you want to launch the application and hit right click. This brings up a window, which is the application launcher. This window is similar to any other graphical user interface window. So right here we have 5 buttons. Each one represents an application. I'll go through them very quickly. First thing is the system status, which just shows the status of a couple things, and then we'll skip calculator Bitcoin miner for now, and then let's go to the profiler. And then the profiler is actually a section-based profiler. It allows you to just profile a section of code in the system. So one of the most interesting things, and probably also the most useless thing about this system, is the fake Bitcoin miner application. And what this is an application that takes a hard-coded Bitcoin block and tries to mine it. It's a Bitcoin block I randomly chose from the main blockchain. And I have an entire blog post about this, but I wrote this as an experiment to compare how an application would run bare metal without a scheduler versus a version of this which would run on Linux with a OS scheduler. And I actually only found that this ran about 8.5% better, but that could have been my fault, but that's what I found. So if you want to check out that blog post, please check it out on BoksOS.com. So let's get out of this. And for the next part of this demo, I will switch over to QEMU on my Mac. So here we are on my Mac. Let's get to the calculator. You just type the expression here. It supports both decimal and hexadecimal notation. As you might have noticed, there is a new button here called Suspend. What Suspend does is essentially suspend and resume on the system. It will save the state of this application to disk, and then you can reboot the system and the state will be exactly the same way. So let's hit suspend and we'll reboot BoksOS, and let's bring up the calculator again. And as you can see, it's in the exact same state as you left it. So this is a source code for the calculator. It's written in the Zig programming language. This is the entry point, this is the main function. And the main thing I want to draw your attention to is this parameter right here, which is the application context. Currently, the application context is a piece of data passed into the application by the operating system. And it currently contains these fields. It's the process ID of the application, the coordinates in which the application was launched, and the frame buffer of the screen. I plan on changing that for security reasons, but that's what I have so far. The main purpose of this piece of data is to actually communicate to the operating system when system calls are unnecessary. So in the future, I plan on adding an event queue here and other pieces of data. So the very last thing I want to show you about this code is just kind of the structure of it. So here we have the main loop, which is for events. Right now it's a system call, but in the future will be part of the application context. And then down here, as you can see, the user interface API is an immediate mode API. We have begin window, we have button, etc. So one of the things I want to point out is the fact that I want to make sure that the user libraries are optional. Though when it comes to the user interface library specifically, I understand the concern that that could fracture the look of the operating system and make things inconsistent. So I want to be mindful of that as I go along with this project. So that's all I have for you today. I hope you enjoyed the demo. I hope you found some value in this project. If you'd like to follow along, please visit BoksOS.com. I also stream about once a week on Twitch. My username is DanBoxer. Thank you very much for your time and enjoy the rest of the conference.
I'll start us off by asking the classic question of how long you've worked on this project.
I think I've been working on this for about a year and a half, I think. But I might have started like an early iteration. Like I experimented with operating system on Raspberry Pi, but I think this iteration is like a year and a half.
If it's possible, people can ping Dan Boxer.
Yeah, I see it. Yeah. Hello, Matt Knight. So suspend and resume is, I plan on it being universal across applications, or at least the option of that. I have to decide whether to make that mandatory, mandatory to support. But I assume for certain applications you probably don't want that, but I do plan on making it very easy to implement and universal. Thank you, Nectro. It was faster by 10%. I thought it would be, but I guess this Linux scheduler is really good, so that's why it wasn't as wasn't as fast as I maybe expected. But question: what kind of hash rate are you getting with the fake Bitcoin miner? I actually don't remember offhand. I have to go back and look at the video, but it was definitely nowhere near what a GPU can do. Everything was running on the CPU. When do you evict application states from disk? So I don't have exactly that. That's something I have to decide, because also I have to consider when you actually change the application, when you update it, how does that affect the state? I don't have a plan for that yet, but that's definitely coming up. How was using Zig for this? It was very nice. It allows me to do exactly what I need to do, and I like certain things I don't have to like byte slices are amazing. Just like slices are amazing. You don't have that in C. So any plans for network support? Yes. Initially it would definitely be from an application communicating, nothing like web browser, at least yet, but any specific goals for BoksOS? So I do. It's more of a plethora of things, and it's kind of any specific goals. Does it do anything interesting that typical OSs can't or don't want to do? One of the things I tried to show, I hope got across, was suspend and resume across applications. That was one thing. There's other things that I'm blanking out about right now. Can you speak about how Zig integrated with the bootloader? Yeah, so the bootloader is also written in Zig, and one of the reasons I chose Zig is because it was very easy to output a UEFI executable, and so the bootloader. Essentially, I compiled the bootloader into a UEFI executable, and then the kernel itself is actually an ELF. And so the bootloader parses and loads the ELF file. Do you run everything in ring 0? So yeah. So currently everything but the calculator runs in ring 0. The calculator actually runs in ring 3, but that's more of like a progress thing. Though another thing to consider is maybe there are certain applications that you absolutely trust that you know, I don't think you would want them running in ring 0, but maybe what you would want more is like sand scheduler or pin it to a core where it's always running. But not yet is everything running in ring 3, but I think that's the plan eventually. Thank you, Loris. Can you please come say hi to the Zig Squadron afterwards? Yes, definitely. And have lunch with us, definitely. Matt Knight, when can I fake mine Dogecoin? Maybe soon. That's I could just like have like a bunch of cryptocurrencies and just like have like fake miners for all of them. Nectro, could suspend and resume be used in a continuous function to help applications survive spontaneous crashes and shutdowns? Yes. So that's one of the reasons that is definitely a thing of kind of availability. And another feature I didn't mention, eventually I wanted to have is runtime patching, patching the operating system at runtime. That's a tricky problem, and I haven't really begun to tackle that yet, but reliability is definitely a goal. What is the plan for suspend and resume for applications that use a GPU? There is no plan yet because I don't have, all I have access right now is a frame buffer. That is a good question. I'll have to research that in the future. I know maybe we can just like, yeah, I'm not exactly sure yet, but that is something to think about. Is this a process model Nix based, Windows style, or otherwise? Oh, so there's no files really in the operating system yet, so there's no like Nix. I'm kind of also another thing is deciding is about the file system and how that will integrate with the operating system. I plan on having kind of applications kind of standalone. My initial thinking is having kind of like applications standalone, and then you have like a file system as kind of like a share pool between them, and also a way of like exporting things. But it is Nix Unix model is not something I'm going for. What sort of hardware drivers do you have? Currently I have a PS2 driver for the mouse and keyboard. I have obviously the frame buffer and an NVMe driver for the suspend and resume. The next driver I'm probably going to try and tackle is USB because I since got a fancy new computer which does not support PS2 mouse and keyboard very well.
We have time for a couple of more questions.
Okay. Can it run Doom? Not yet. Eventually, hopefully. Have you thought about compiling the operating system on boot? I have not, actually. But that would be something to think about. I haven't thought about that at all. So thank you for bringing that idea to my attention. Marley, how do you serialize process state? And are processes loaded at the same address? So So the last question, are processes loaded at the same address? It is actually, so I compile the application. I'm only talking about the calculator here because that's the only thing that's really compiled separately. That just uses the entry point. It just uses the data in the ELF file. So it's whatever the ELF file says. As long as the ELF file doesn't load into high memory, it will load wherever the ELF file says. And how do I serialize process state? So the way it works is I basically have a working set of page tables, and then I go through the working set and just save everything out to the NVMe. And then right now it's hard coded to load everything at address 0 on the NVMe because the way the NVMe works is basically it's not random access, but you just have a set of like 512 blocks, and so everything loads from address 0 right now because there's only one application.
Let's give a round of applause to Daniel Boxer.
Thank you.